Hi, hello everyone. So in this video, we're going to discuss the concept of integration by parts. Now, this is another advanced technique in getting the antiderivative of more complicated types of functions. Okay, before we proceed with the discussion of this method, balikan muna natin yung isang technique na tinuro nung differential calculus, yung product rule for derivatives. Okay, the product rule for derivatives, as the name suggests, is applicable kapag kinukuha natin yung derivative ng isang function which may be expressed as a product of two or more functions. Okay, so for simplicity, let's consider two functions u and v na gusto natin kunin yung derivative ng product nila. So what we do is we get u of x times the derivative of v of x plus v of x times the derivative of u of x. Now for simplicity, ang ginagawa lang natin is we normally omit yung of x part dun sa pagsulat ng functions. So we have the derivative of uv as u dv plus v du. Okay, so this one will be the basis of integration by parts. Okay, integration by parts, if we have two functions of x, u, and v, which have continuous derivatives, the integration by parts formula is given by this one. The integral ng u dv is equal to uv minus integral ng v du. So how we arrive at this formula is by the product rule. Okay, recall from the product rule na kapag kinuha natin yung derivative ng product of two functions uv, this is u dv plus v du. Okay, now if we get the antiderivative, okay, by one property of integrals, we know na pwede nating isipin na yung antiderivative ng sum is yung sum ng antiderivatives. Moreover, yung differentiation and integration are inverse processes. So, magka-cancel lang tong part na to. So, we're left with uv equal to the integral ng u dv plus integral ng v du. And then, we can simply solve for the integral ng u dv. So, integral ng u dv is equal to uv minus integral ng v du. So, dito galing yung formula natin for integration by parts. Okay, so it is quite essential that we are able to choose dun sa form ng function natin kung alin yung u at alin yung dv. Now, luckily for us, meron ng mnemonic that was established para mas mapadali yung choice natin kung alin yung u at kung alin yung dv. Okay, we're going to follow this mnemonic, yung LIATE natin. Okay, LIATE stands for logarithmic, inverse trigonometric, algebraic, trigonometric, and exponential. Okay, so given the integral, pipiliin natin yung u kung alin yung mas unang mag-a-appear dito sa mnemonic natin. Okay, and then yung matitira, yun yung magiging dv natin. So for example, dito sa integral na x sin x dx, dito sa ating integral, we have x saka sin x. So, and based dun sa ating mnemonic, mauuna ang algebraic sa trigonometric. So yung choice natin for u, so let u be equal to x. So it would follow that du is equal to dx. Now with this representation, natira sa atin is yung sin x dx. So yun yung ating dv. So dv is sin x dx, and we can get v by getting the antiderivative of dv. So this will give us cosine x. Next is we simply apply yung integration by parts formula. For simplicity rin, I will refer to integration by parts as IBP. So this is equal to uv, so x cosine x, minus integral ng v du. Okay, notice na meron pa rin natirang integral, which is okay. That's perfectly fine. But the goal is this integral should be easier to solve. Okay, at madali naman isolve ang integral ng cosine x, which is negative sine x. So we have x cosine x minus negative sine x plus c, or x cosine x plus sine x plus c. So this is the antiderivative of x sine x dx. Okay, let's have another example. Okay, suppose we want to find the integral of ln x over x cubed dx. Okay, let me just rewrite this para mas clear. We can think of this as the integral ng ln x times 1 over x cubed dx. Again, ang basis natin ay LIATE, which stands for logarithmic, inverse trigonometric, algebraic, trigonometric, and exponential. So obviously, meron tayong logarithmic function dito. So yun na yung choice natin for u. So let u be equal to ln x. So it means that du is 1 over x times dx. Then ang natira sa atin is an algebraic function. So dv is dx over x cubed. Again, we can get the value of v by getting the antiderivative of dv. So v in this case is equal to negative 1/2 x raised to negative 2 by using the power rule. Okay, so we have uv, so ln x times negative 1/2 x raised to negative 2 minus integral ng v du. Okay, then simplify. This would be negative ln x. Sulat ko lang in this way over 2x squared. Then we have minus minus. So plus integral ng 1/2 x raised to negative 2. Pwede natin isipin na 1 over 2x squared. And then may x rin tayo sa baba. So 1 over 2x cubed times dx. So sulat ko na ng mas maganda. So this will now be dx over 2x cubed, which is easier again to get the integral or the antiderivative. Okay, negative ln x over 2x squared plus this part here, we can simply apply the power rule to get that its antiderivative is negative 1/4 x raised to negative 2. And of course, our constant of integration. Ay simplify na lang natin as negative ln x over 2x squared minus 1/4 x raised to negative 2 plus c. By the way, pwede nyo pa ito i-simplify, pero okay na rin naman na ganito na lang isulat natin para rin mas clear yung process ng integration by parts natin. I know in some cases, we may have to apply this technique more than once in order to get the antiderivative. Okay, so for instance, we want to find the integral of x squared times e raised to 3x dx. So of course, again, with our guide, LIATE, ang choice natin for u is equal to x squared. So it follows that du is 2x dx. And then we have dv as e raised to 3x dx. So our v is e raised to 3x. Okay, so by integration by parts formula, this is equal to uv. So x squared, oops, sorry, this should be over 3. Yan. So x squared times 1 over 3 e raised to 3x minus integral ng v, which is e raised to 3x over 3 times 2x dx. Okay, let me just separate these two. Okay, simplify natin. This one is x squared over 3 e raised to 3x minus 2x, or sorry, integral ng 2x over 3 e raised to 3x dx. Now, yung integral na nakuha natin, we again have to use integration by parts. Okay? So, this time, dito sa integral na to, we again have to use integration by parts. So, let's say u bar be equal to 2x over 3. So this would mean that du bar is 2/3 dx. So yung natira is dv bar. This is e raised to 3x dx, or v bar as 1/3 e raised to 3x. Okay, so x squared over 3 e raised to 3x minus, this time, mag-a-apply na integration by parts pero sa u bar saka sa v bar. So we have 2x over 9 times e raised to 3x. This is u bar times v bar minus the integral ng v bar du bar, or 2 over 9 e raised to 3x dx. And then we again simplify. So x squared over 3 e raised to 3x minus 2x over 9 e raised to 3x plus integral ng 2 over 9 e raised to 3x dx. Okay, doon sa natirang integral, we don't really have to use integration by parts, pero kailangan natin mag-integration by substitution. Okay, in integration by substitution, we can let a be equal to 3x and perform the necessary steps. Okay, so simplify. So x squared over 3 e raised to 3x minus 2x over 9 e raised to 3x plus 2 over 27 e raised to 3x plus our constant of integration. So this is our answer. Okay, so in some cases, we may have to apply integration by parts more than once para makuha natin yung antiderivative ng function natin. Okay, this next example is a bit more complicated again. So, clue ulit na we will be applying integration by parts more than once in order to get this antiderivative. Okay, with our choice of u and dv as u be equal to sine x. With u equal to sine x, this would mean that du is equal to cosine x dx and dv is equal to e raised to x dx. Okay, so if we apply integration by parts, this would be uv. Pero isulat ko na in this way. uv minus integral ng v du. Okay, do sa integral ng e raised to x cosine x dx, we again have to apply integration by parts. So, lagay ko dito. So, we let u bar be equal to cosine x. So, du bar is negative. Should be negative sine. So, dv bar is equal to e raised to x dx. Or v bar is equal to e raised to x. Okay, so we have e raised to x sine x minus, again, apply integration by parts. This is e raised to x cosine x minus the integral of negative sine x times e raised to x dx. Simplify. E raised to x sine x minus e raised to x cosine x plus integral ng e raised to x sine x dx. So after applying integration by parts twice, notice that pumalik tayo dun sa original na integral problem natin, yung e raised to x sine x dx. So dito, gagamit tayo ng concept ng algebra that we treat these two as like terms, pero may error pala ako. So this one, notice na minus minus, so magiging plus siya. However, may negative sign pa ulit sa labas. So this should be minus integral ng e raised to x sine x dx. Okay, as I was saying, gagamit tayo ng concept sa algebra kung saan we treat this and yung original integral natin as like terms. So, sulat ko ulit siya dito, e raised to x sine x dx. What we do, lilipat lang natin tong nasa right-hand side sa left-hand side. So, we have 2 times the integral ng e raised to x sine x dx equal to e raised to x sine x minus e raised to x cosine x. So since we want to solve the integral of e raised to x sine x dx, we divide everything by 2. By doing so, will give us e raised to x sine x minus e raised to x cosine x over 2 plus c. So this is our antiderivative. Now it goes without saying that this technique will also apply sa mga definite integrals. So for our last example, let's solve this definite integral. Okay, the definite integral from 0 to pi over 2 ng x cosine x dx. So again, following LIATE. So we let u be equal to x. So du is equal to dx and dv equal to cosine x dx. So v is equal to sine x. So using integration by parts, this is uv minus integral ng v du. Then ito, we will evaluate this from 0 to pi over 2. Okay, so simplify. We have x sine x. Then the integral of sine x dx is negative cosine x. So minus negative cosine x. We have plus cosine x. We evaluate this from 0 to pi over 2. Apply FTC. So we have pi over 2 times sine pi over 2 plus cosine pi over 2 minus, so at x equals 0, this would just be 0 plus cosine 0. Okay, sine pi over 2 is 1. So we have pi over 2 and cosine pi over 2 is 0. Likewise, we have 0 plus cosine 0 is 1. So our answer is pi over 2 minus 1. Okay, so again, integration by parts. Magamit to kapag yung form ng ating integrand can be treated as a product of two functions. We just have to identify kung alin dun yung u at kung alin yung dv, and it is normally given if we follow the mnemonic LIATE, which again stands for logarithmic, inverse trigonometric, algebraic, trigonometric, and exponential. Okay, so this is the end of this recorded or this lecture video for integration by parts.